Welcome to everyone. Myself Parmesh and my project mates are D. Ajit Kumar and V. Arun. We are from Tech Engineering College, Department of Civil Engineering, and my guide is Mr. R. Rajeswaran Sir, Assistant Professor, Department of Civil Engineering, Tech. Our project objective and scopes are to reduce the load on the superstructure by reducing the cross-sectional area by using lightweight precast wall panels, and also to reduce the power consumption by using insulating material, to increasing the speed of construction. It's very cost effective, and also to reduce the demolition waste. It's very easy handling and replacement, eco-friendly. Introduction. Generally, conventional concrete is strong but higher sulfite, and this will take lengthen construction speed and more workers to be needed. Due to increasing worker cost increases, and construction industry suffer from low productivity, safety and quality control due to syndrome. Using this precast lightweight concrete to substitute conventional concrete because of its advantage and environmental friendly. This figure shows we placed insulating material high density polystyrene, and top and bottom we placed a wooden panel, and this example shows in hotter days maintain nominal room temperature, and air conditioning withstand for more hours from normal houses. In rainy days, room temperature maintain moderate, and heat generating from our body stay inside, which not absorbed by the wall. Literature review. From the paper of thermal insulating concrete wall panel design for sustainable built environment, this paper said thermal insulation of building by adding a gypsum layer inside concrete is presented, and SIP, namely structural insulated panels, having advantages of minimal material wastage and labor savings, which having potential to save house builders time, money, as well as retaining the controlled quality. In this paper, we taken the panel structural behavior was studied, and we observed crack pattern, low deflection profile, and efficiency of shear connectors. And this precast is sandwich panel innovative way of construction, and we taking material test for our project using a natural river sand and a coarse aggregate and OPC cement 53 gauge. We getting the values of specific gravity, fineness modulus, and grading zone is 1, and we tested specific gravity and initial setting time, final setting time, fineness for the cement. Mix design for M30 grade, we get it the mix ratio of 1:1.97 is to 1.70 for 10 mm aggregate. Composition test results for 28 days. We tested 3 samples, and we kept in curing for 28 days. We getting the results of 30.63 Newton per mm square. Average composition strength we shown in the graph. Split tensile for a cylinder, we getting the values of 2.65 and 2.64 and 2.46. We getting the average values of 2.58. We get it in the values in the ranges of ratio, and we tested flexible tensile strength, and we tested 3 samples, and we get in the value of 3.87, and in the graph shows the 3 values. And this is our wall specimen and reinforcement details. Mole size, our project mole size is a wall panel 750 mm length and 750 mm wide and 100 mm thickness. And specimen A we provided 6 mm die of 300 mm spacing, and specimen B we provided 6 mm die of 150 mm spacing. We placed insulation material center. These dimensions are 700 mm length and 700 mm breadth and 40 mm thickness. Reinforcement details: 12 bars for 300 mm spacing and 20 bars for 150 mm spacing. This detailing CAD diagram for 300 mm spacing, and left side is for 150 mm spacing. This is detailing of our wall panel. Cross section of specimen. In center we place the polystyrene, high density polystyrene. This is our thermal insulating layer for the wall panel for 40 mm thickness, and we tested in a universal testing machine generally used to test a compressive strength of specimen, which load is applied at the rate of 25 kN per minute. uh, we shown in the figure, wall panel is placed in the UTM, and in the upper and bottom layer we place two plates and giving a load uniformly distributed to the wall panel. And in before that, in the dial gauges used to measuring the bendings of the wall panel. It's by manually we plotted a graph. We observed a crack patterns in the wall panels as shown in these figures. And this is our load details. Specimen A and specimen B is we getting the load of 312 and 322, and average load is 317, and wall 2 for 445 and 453 we get it for 419 kilonewton, and wall 3 is a conventional wall, we get in the value of 586, and 592 we get in average value of 589 kilonewton. Deflection details for 300 mm spacing. For wall A, specimen A and specimen B getting the deflection value of left deflection, right deflection value due to the tensile and compressive test. Due to present of tensile and compressive behavior, we get in the left and right direction positive and negative values are we get it. So we plotted a graph for specimen A and specimen B, we getting buckling details for 300 mm spacing. This is for deflection details for 150 mm spacing, and specimen A says specimen B likewise same we telling in the 300 mm spacing deflection details. This is the buckling details of 150 mm and specimen A, specimen B, and this deflection details for conventional wall. Specimen A and specimen B we get observed left deflection and right deflection value, and we plotted a buckling details for conventional wall. This is a load versus area of reinforcement. We plotted a graph for observing. We from the graph we formed the equation of P equal 0.58 AST plus 120.2, and P is the load we get in the area of steel. Maximum reinforcement provided equal to 4% of cross-sectional area. It is not exceed the 4% of cross-sectional area. Depend of the grade and height of the wall, thickness to be determined. Weight and cost analysis. We tested and analyzed our wall panel is very economical and lightweighted. For that, our wall panel checked for self weight is 0.91, and brick wall is 1.12, and concrete wall is 1.40. And cost wise, our wall panel is 3,375. For the same size we designed. For brick wall it requires 4,500, and concrete wall it retains 6,000 and above. And we analyzed in software our wall panel and conventional wall panel using this SAP software. Data centered for the insulation material for unit weight and Poisson ratio, Young modulus, and coefficient of thermal expansion. Both conventional and wall panels models are made at 100 kN per meter. Load is applied axially and investigation is done. This is a conventional wall model, and we tested in SAP software. We get it the details of axial force details and stress details and moment details we get it. And result of our wall panel, we place 100 mm thickness, and inside 40 mm is high density polystyrene we placed, and we analyzed for the load for axial force details and shown in center, and in this left side we showed the shear details, and bottom we showed moment details. Result and discussion. Result for 300 mm spacing, minimum spacing, the ultimate load is 317 kilonewton. For 150 mm spacing, ultimate load is 449 kilonewton. Unit weight obtained for wall panel is 0.916 kilonewton per meter cube, and maximum buckling for 300 mm spacing is 6.8 mm, and maximum buckling for 150 mm spacing is 1.45 mm. For conventional wall, ultimate load is 589 kilonewton. Unit weight applied for conventional wall is 1.40 kN per meter cube. And the unit weight and discussion, the unit weight of wall panel is reduced, and so cross section of structural element is reduced, so less cost required for construction. Thus we can design the wall panel for required load so that we can reduce the minimum requirement required for shear wall. By considering both load and power consumption, wall panel is better than the conventional concrete weight. For M30 grade wall panel, if the load is known, we can calculate the area of reinforcement using the relation. This relation we get it from this graph, area of steel versus load future study, and we get satisfactory result in using M30 grade concrete and experimental evaluation on other required grades. We can formulate different equations and proper design for this wall panel can be given. We can also study the behavior of wall panel by keeping the area of reinforcement as constant and varying the thickness of the insulation material. Thank you.